You know that shirt you're wearing? Or those jeans? They've got a secret. Yeah, woven into every single thread is this whole story. Not just about cotton and dye, but about a surprising amount of energy. So, let's dive in and uncover the hidden energy footprint of our clothes.
Okay, to really get this story, you first have to understand the scale. And this chart, it just nails the big picture. As the world's population has grown, our demand for clothes has just absolutely exploded. I mean, look at that solid line. It's a near vertical climb in production. We're not talking about some small industry here. This is a colossal global machine churning out millions upon millions of tons of fabric every single year. So, what does it actually take to power this massive machine? It's time to unpack the real energy cost that's hidden in every yard of fabric you own. Now, this is where it gets really interesting. When you think about the cost of making clothes, you probably think of the raw materials, right? Like cotton or maybe labor. But check out that energy row. In India, it's 12% of the total manufacturing cost for cotton yarn. In Italy, it's 10%. Across the board, energy is often the third or even fourth highest expense for a textile mill. So what this tells us is that energy isn't some minor detail. It's a major cost driver.
Okay, so that begs the question, right? If textile mills are spending all this money on energy, where is it actually going? Let's follow the flow and find out.
Let's get right to it. You know, from turning raw fiber into yarn to dyeing it that perfect color, the whole process is pretty complex. But where are the real energy hogs inside the factory?
And here we go. This is the answer. This chart breaks it all down, and two huge slices just jump right out. A whopping 28% of a factory's energy goes to motor-driven systems. We're talking all the machines that are spinning, weaving, and moving stuff around. Then another 28% goes into making steam, which is absolutely essential for what they call wet processing. You know, things like washing, bleaching, and dyeing fabric. Put those together, and that's more than half the entire energy bill, right there.
But hold on, because here's where the story takes a really shocking turn. This chart shows what happens to all that energy once it enters the factory. Only 64%, that big purple slice, actually gets to do useful work. The rest? It's just lost. Look at all those other slices. Motor system losses, boiler losses, distribution losses. It's like trying to fill a bucket that has a massive hole in the bottom. Let that number sink in for a second. 36%. A staggering 36% of the energy that's paid for and brought into a typical U.S. textile mill is just wasted on site. Now why? Well, it's often a mix of old, inefficient equipment, leaky steam pipes, and just a relentless focus on production speed over efficiency. When the main goal is just to get the product out the door, energy conservation can kind of take a back seat. And this isn't just an environmental issue, it's a huge economic leak.
But here's the good news. Where there's waste, there is always opportunity. This massive energy leak is also a massive chance to find some hidden savings and turn all that waste back into a resource. You know, the source report we're drawing from is super optimistic, and for a really good reason. It details nearly 190 different energy efficiency measures. And I love how it frames waste here, not as a dead end, but as a resource in the wrong place. The potential for savings is right there, just waiting to be claimed. So where do you even start? Well, the smartest approach isn't just about fixing one machine. It's about having a strategic plan for the whole organization. This cycle here shows the key. It all starts with a commitment. Then you assess your performance, create an action plan, implement it, and then you evaluate your progress. It's this continuous loop of improvement that really makes efficiency part of the company's DNA.
And some of the solutions are just incredibly clever. This here is a schematic for something called a counterflow washing system. So instead of using fresh hot water for every single washing tank, it does the exact opposite. The fresh water comes in at the very end, where the fabric is already cleanest, and then it gets recycled backwards, tank by tank. It gets progressively dirtier as the fabric gets cleaner. It's brilliant. And this simple change can cut energy and water use by up to 62%.
And here's the real kicker. This stuff makes incredible business sense. Just look at the payback periods on these investments. Recovering heat from hot wastewater, that can pay for itself in less than 6 months. Properly insulating a boiler, you're looking at about a year. So saving energy isn't just a cost, it's one of the best investments a factory can possibly make.
All right, so all of this is pointing to a really exciting future, one where our clothes are made smarter and way more sustainably. So what's on the horizon? Let's take a quick look. And the innovation just doesn't stop. These emerging technologies are poised to completely change the game. I mean, imagine dyeing clothes not with water, but with pressurized CO2 that you can just recycle over and over. Or using ultrasound waves to cut down processing times and temperatures. Or using foam, which is mostly air, to apply finishes instead of soaking fabrics in water. This is really the cutting edge of textile manufacturing.
This quote from the source report really just says it all, doesn't it? This isn't about making a compromise. Investing in energy efficiency is a total win-win-win. It's a sound business strategy that slashes costs, it's way better for the environment, and honestly, it often leads to higher quality products.
So at the end of the day, we're left with this one, final, really powerful question. We have the technology. We absolutely have the business case. We know that being efficient is profitable. The path forward is crystal clear. So what's stopping us?